let's do some phase change problems. Now, remember, when we do phase changes, that you're basically always going to be going from a solid to a liquid, or liquid to solid, and then the heat is going to be m times the latent heat of fusion. Now, for convenience sake, a lot of times I will use the latent heat of fusion as LF, and that's the same thing as delta HF. Delta HF may be more technically correct, but 100 years ago when I did this, I learned LF. Now, when you go from a liquid to a gas or back, then the heat is going to be m times the latent heat of vaporization. And for the exact same reasons, a lot of times I will use LV instead of delta HV. Now remember, if you're ever going, here's my graph here, from a solid, and here we're melting, and here we're going up to boiling again. You always have to add up all of the heat from the individual sections. So these can get to be kind of complicated problems. Whenever you have them and you have to do them in parts, draw a picture and just do one section at a time. Remember when you're doing them where you're changing the temperature, then the heat is MC delta T. Now, how much energy is released by 100 grams of ice at 0 Celsius as it melts to water at 0 Celsius? Okay, so this is a phase change. So the mass is 100 grams, and the latent heat of fusion is 334 joules per gram. So the heat is M delta HF. So it's 100 grams. Now, delta HF is 334 joules per gram. Now, let's check our units. The grams cancel. So now we're able to multiply straight across. This is 334.00, and I'm left with joules. Make sure you check your units. Now, you're asked to melt 0.1 kilograms of ice at its melting point and warm the resulting water to 20. How much heat is needed? Okay, this is one of those I told you about. The first thing we're going to have to do is melt it, and then we're going to have to raise the temperature. So, one part at a time to melt. All right, I need the mass, which is 0.100 kilograms. Now, everything we do is in grams, so let's convert this to grams. I know 1 kilogram is 1,000 grams, so the mass becomes 100 grams. Your life will be a lot easier if you do it that way. And then the latent heat of fusion is 334 joules per gram. So the heat to melt it is going to be M delta HF. So this is 100 grams times 334 joules per gram. Grams cancel, I'm left with joules. So this is 334.00 joules. Okay, this is the first part of this. This is just the heat to melt it. Now we have to warm it. So when it's a liquid, I know the heat that's going to be added is MC delta T. Well, the mass is 0.1. The heat capacity for water is 4.186 joules per gram Celsius. Now, T final is 20 Celsius. T initial is 0 Celsius because it started at 0 and ends up at 20. So delta T is T final minus T initial. So it's 20 minus 0, or 20 Celsius. So the heat, I'm going to come up here, Q is MC delta T. The mass is 100 grams. C is 4.186 joules per gram Celsius. And delta T is 20. Let's see what happens when I multiply 100 times 4.186 times 20. I get a very strange number. 100 times 4.186 times 20 is, okay, 8,372. Let's see, what are my units? Joules, grams go away, Celsius goes away. I'm left with joules. So the total heat is the heat to melt it plus the heat in liquid form. So it's 33400 joules. I'm going to write it like a regular math problem. 8372 joules. And when we add these together, what do I get? 33400 plus 8372. I get 41772 joules. Cool. Now, how much energy is absorbed by 0.035 grams? So that's my mass of water at 0 degrees as it freezes. So the latent heat of fusion is 334 joules per gram. So the heat absorbed is M delta HF. It's 0.035 grams times 334 joules per gram. So let's clear that out. 0.035 times 334 gives me strange number. I'm having trouble with my calculator today. 0.035 times 334 is 11.69. Let's see, the grams have canceled, so I'm left with joules. How much energy is absorbed by 125 grams of water? So my mass is 125 grams. As it boils at 100 Celsius and becomes steam at 100 Celsius, the latent heat of vaporization is 2,260 joules per gram. Well, the heat is going to be the mass times the latent heat of vaporization. So this is 125 grams times the latent heat of vaporization, which is 2,260 joules per gram. Let's see. Grams are going to cancel, so I'll be left with joules. 125 times 2,260 is 282500 joules. Now, how much energy is released when 27 kilograms of steam is condensed to liquid? Let's see. This is tricky because I gave you the mass in kilograms again. So I know 1 kilogram is 1,000 grams. So this is 27123 grams. So the latent heat of vaporization is 2,260 joules per gram. So the heat is going to be the mass times the latent heat of vaporization. So this is 27123 grams times 2260 joules per gram. Grams cancel, I'm going to be left with joules. So 27000 times 2260 gives me a very large number. Let's see. 6102 and 1, 2, 3, 4 zeros. Let me put in my commas here. Did I do that right? 1, 2, 3, 4 zeros. Yeah. All right. So this is 6.1 times 10 to the, let me count them, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. So it looks like this answer right here was off by 1 0. Man, teachers are making mistakes all the time.